Alright, so tonight we're going to talk about different ways to find slope. Slope's something you've done in middle school, but I just want to make sure that we do a quick refresher and that you understand what we're talking about. So you've got the date, the page number, the learning target, and you have this in your table of contents. And if you don't, please do so and then continue on to the next slide. Remember that everything that we've been talking about so far this unit has been linear equations, which again means straight lines. So we can only use a slope for a straight line. Okay, they have a consistent pattern all the way up, which makes it a straight line. So slope only works for straight lines, linear equations, not something that curves like this. Alright, so the slope is technically known as the ratio of the vertical change to the horizontal change. Think about vertical change being your y values and the horizontal change being your x values. And so what we've got here is what you're used to hearing. Slope is equal to rise over run. And again, we were saying the vertical change, the up or down change, that would be your y value. So what you're technically going to do is you're going to get an ordered pair. And you're going to take that ordered pair. Let's say I have, we're going to call it x1, y1. This is my first ordered pair. My first x value, my first y value. That's all that means. And then we're going to have x2, y2, second ordered pair, second x value, second y value. And so the formula here is subtract your y values. So it's like the difference in your y values, the change in your y values, over the difference in your x values. So it's how far between your y values and how far between your x values, which is why when we get to the graphing in a little bit, we're just going to count the difference between them and see how far apart they are. Okay, so example 1, I have two ordered pairs. So again, all this means is x1, this is my first x value. y1, this is my second y value. That's all that means, x1, y1. Okay, in my second ordered pair, this would be my second x value that I've used because I already had one over here. And my second y value would be y2. That's all that means, x1, y1, x2, y2. So now I'm just going to put it in my slope formula. M stands for slope, and it's equal to rise over run. And you subtract the y values over subtract the x values. So y2 was positive 1. So I put 1 in for y2 minus y1, which was 0. Over x2, 3, minus x1, negative 2. So now I'm just going to solve that and figure out what my slope is. 1 minus 0 is 1. 3 minus negative 2. Remember, minus negative means plus positive. So you've got 3 plus 2, which is 5. So my slope is 1/5. And if I was to graph this, this is my rise over run. This is how I get from each point to the next. So you would count up 1, right 5, because it's positive. Because it's positive, I would go up 1, and you always get in the habit of running to the right. And that'll help make sure you go the right direction every time. Example 2. This looks a lot harder, but it's not. What I had in the last example was just two different ordered pairs, and I plugged it in, got my answer. Here, look at how many ordered pairs I have. I have 1, 2, 3, 4, 5, and you can pick any two out of those 5. So just to show you that I can do that, I'm going to pick this one, and let's just pick one of the middle ones, this one, just to do it. You can pick any two you want to, try it, and you should get the exact same answer. So I'm going to use the ordered pair 3, 2 as my first ordered pair. And I'm going to use the ordered pair 9, 6 as my second one. And then I'm going to find the slope between them. So, M equals y2. So if I labeled them, this would be x1, y1, because it's my first ordered pair, x2, y2, because it's my second ordered pair. So now I'm just going to plug it into the slope formula. My change in y's over my change in x's. So y2 minus y1. And then x2 minus x1. 6 minus 2 is 4. 9 minus 3 is 6. But that's not completely reduced. I can reduce it. This divides by 2, and so does the other one, 6, and you would get 2/3 when you reduce it. So this is my slope, 2/3. And it's positive. So again, if I was going to move from point to point using this slope, I would go up 2, right 3. One more example between 2 points just to show you a different way to do it. If I plugged it in, x1, y1, and x2, y2. So m equals y2, which is 2, minus y1, which is 2, over x2, which is 2, minus x1, which is negative 1. So when I do that, I get 2 minus 2 on top, which is 0, and then minus negative is the same thing as plus positive, over 3. Now, 0 divided by 3 is actually 0, so my slope is 0. Okay, so when we're going to graph these, what you're going to do is you're talking about rise over run, or your change in your x values versus change in y values. So this is why we subtracted them, to see the difference between the y values and the difference in your x values. So what you're going to do is you're just going to count between 2 points, and you're going to go from left to right, because when we read anything like words, you read from left to right. So I'm going to pick any 2 points on this graph, and I'm going to show you all the points. The points are where it crosses, like this, right here. There's a point, doesn't cross again till here. Here's another point, crosses again. Here's another point, here's another point. And slope, it's a straight line, which means it should be the same all the way across. So it doesn't matter which 2 points I pick. I could pick this one and this one, or I could pick this one and the one above it. It does not matter. I'm just going to pick these 2, and I'm going to count. From here to here, it goes up 1, 2, 3, right 1. Okay, so I went up 3, and then I went right 1. So this should make sense that it's rise over run. And rise is the amount that it goes up or down. If it goes up, it's positive. And if it goes down from left to right, it's negative. And you always talk about how much it runs to the right on the bottom. So that should make sense, though, because rise, remember my y values were on top, and rise, that's how far I go up and down. So that should make sense, because this is what changes from there to there. So I went up 3, and I went up 3, so it's positive 3. And then I went to the right 1. So my slope is 3 over 1, or just 3, because 3 divided by 1 is 3. Last example, I'm going to show you where all the points are. So there's a point here, there's a point here, point here, point here, point here, point here. And notice from left to right, this one's falling. It's going to go down. So I'm going to show you that you don't have to pick 2 consecutive points, and I'm going to pick these 2. So I'm going to count. You can go down 1, 2, 3, 4. So I went down 4, and I went to the right 1, 2. So if I'm going to do my slope, m is rise over run. I went down 4. Since I went down, I'm going to show that by doing a negative 4. And then I went to the right 1, 2. So it's negative 4 over 2, which reduces to negative 2. Or negative 2 over 1, whichever way you want to do it. And you could pick any 2 points and had it end up reducing to negative 2. Okay, so that's how you find the slope of the line between 2 points or just on a graph.